Hello everyone, now I will demonstrate task 2, conducting TDD unit testing activities using Python. We need to implement the function which determines whether a point is inside a given rectangular box and return true or false. I will do 3 test cycles, test 1, test 2, and test 3. Each round follows TDD. Write a test to make it fail, then modify the code to make it pass. And I will use the graph to display the points and the rectangles for easy explanation. I fix a rectangular example. The total left corner is at 1020 with a width is of 10 and the height of 8. And the x range is 10 to 20, y range 12 to 20. I write a function that draws a rectangular border and the position of the current test point each time. I also draw the 4 dashed line to represent the boundaries left, right, top, and bottom. This way you can immediately see whether each test point is inside, outside, or on the boundary. I also write a run test function that prints the expected and actual value for each test and marks it as pass or fail. We start the cycle 1. In the first round, I started with the simplest scenario, a point inside a rectangle. I chose the test point is 16 and 15. First, look at x is 15, falls between 20 and 10. Looking at y is 16, falls between 12 and 20. So this point is completed inside the rectangle and the expected result is true. I'm now writing text 1, and the expected result is true. According to TDD rules, I first write the simplest stub function vision v0. v0 directly returns false, so text 1 will definitely fail. I ran the test and saw fail, which means the test is indeed driving the implementation. Next, I made a smallest changes to get text 1 to pass. I will first implement the x direction check, left less than equal point x, then right. This way the point x of test 1 is within the range, so it returns true and test 1 becomes pass. But I emphasize the v1 is not complete because I haven't checked y. In the next round, I will add a new test case that causes it to go out of bounds in the y direction, forcing us to improve the function. In the second round, I tested the outside scenario. Click outside the rectangle. I specifically chose point is 15 and 25. You see that x is 15 is still within 10 and 20, but y 25 is already above top 20, so the point is above the rectangular, so it should return false. The reason for this choice is that v1 only checks x, which will cause it be misclassified as true, so we can see the test fail. I'm now run the test 2, and the expected result is fail. Run the older version v1 first, because v1 only looks at x and return true. This will fail. This is the key to TDD. Test point out that we are missing the y-axis judgment. Now I have upgraded to V2 and added the y judgment. The legal range for y is from bottom equal top minus height to top. That is bottom less than point y less than top. At the same time, the x direction is also left less than point x less than right. Here, I deliberately use strict less than and more than, only ensuring that points in the true interior are true. This way, test 1 inside should still pass. Test 2 outside should also pass because y equal 25 is not in the range. After running, I can see test 1 pass and test 2 pass. However, because I used the strict comparison, points that fall exact on the boundary such as x equal left or y equal top are considered not inside. So in the third round, I will use boundary points to drive the final version. Third round test boundary, the point is on the rectangular boundary. I chose the point 10 and 16. Here x is 10 exactly equal to the left boundary, y is 16 is still between 12 and 20. The question usually counts the boundary as inside, so the expected value is true. But our current V2 use strict less than, which would exclude x equal to 10, so it should fail. I run the test tree. The result will be fail, which means we really need to include the boundary. I'm now run the final vision V tree. Change the judgment to left less equal than point x, less than equal right. Change the judgment to bottom less equal than point y, less than equal top. This way, the inside point is still true. The outside point is still fail. The boundary points are now also true. I reran test 1, test 2, and test 3, and all the 3 tests passed. Completed 3 rounds of TDD, 1 new test per round, falling first and then passing, gradually refining the implementation. Finally, I will briefly elevate the expression of TDD. I think the benefit of TDD is that the goal is very clear. Add only one minimal test at a time. Allow the implementation to grow incrementally as needed. It also prevents me from writing too much logic at once and making mistakes because every step is tested and regression tested. The downside is that it can seem slow in the beginning because you have to write tests before you write the implementation. However, it can significantly improve code currentness and maintainability, making it particularly suitable for functions like collision detection where logic is prone to boundary issue. Thank you. That's all.